with yesterday was on number 26 on your review. So let's look at that one for now.
What number?
26.
Sorry.
You'd think that I just was omniscient, but I didn't.
Yeah.
Alright, so looking at number 26, it says graph it and then find the domain and find the range. So all we have to do for that, guys, is dig out our handy dandy calculators, and most of the time, I'd say 95% of the time, if it says graph, we're just going to plug it in our calculator. Maybe even a bigger percent than that. So I'm just going to go to my y equals. I'm going to clear out the garbage, and I'm going to put in the square root of x plus 2, and then I'm going to remember to end my parentheses, so that I know that's where that is.
Could you scoot it over a teeny bit?
Outside of my parentheses.
Thank you.
Yeah.
Perfect.
So, what we do then is just hit our grapher button. And if we have like a normal window, we can see that our picture is of the square root function, which remember, original function for the square root function. Hold on a second. Oh, the chair. Originally, the square root function started at the origin and went up in this direction. But if we looked at our equation, our square root function is going to move down 4, right? And it's going to move to the left 2. Does everybody remember that? Or kind of anyway,
Yes.
now that I reminded you? And so we could check our original function, that kind of like that, has moved down about 4 and over 2 to the left. So if we were to graph it then, we do have some glaring going on here. We could just sketch the graph, and I just want you to mark that you were over 2 and down 4. So I should be able to find the starting point. Goes over 2 and down 4 and kind of like goes up like that. You know, we did it with poker chips. The lawyer was in wherever you were. Where were you? New Mexico?
Mm-hmm.
Yeah. So, starting here, you're going up and to the right. Now, that's part 1. So we would get all of our credit here for the graph of the function because we have some labels. If you don't want to make the hash marks, you could have just said that was -2, -4, that point there, and that would still give you all the credit. If you don't put your labels in, you will lose some credit. So make sure on your midterm you put your labels in. And then it says, what about the domain and the range? Well, the domain is all the numbers in your graph that equal x. And the range is all of the numbers on your graph that equal y. So I'm going to look at my x-axis first. Thank you. And my x-axis, the one that's horizontal, it looks like my graph starts down here at -2, correct? Is that where my graph starts? -2?
Yeah.
Yeah, we just said that a minute ago, right? So, and my graph continues to go up and on to the right. Does it go on forever to the right? Yes, because it's got a little arrow here on the end. So this function is going up and to the right forever. So my starting value for x is -2, right? And it goes up forever in my x direction. So I could say that my domain was for all of the x's, they have to be greater than or equal to -2, because I start at -2 and I keep going on and up forever. And the same thing then for my y's. And some people write this -2 to infinity or something like that. You could do that too. I just like x greater than or equal to -2, but it doesn't matter. My y's, I'm going to do the same thing. I'm going to look at my y-axis. And it looks on my y-axis like we're starting at -4, correct?
Yeah.
Yeah. And I'm going up and up and up and up and up forever. So my y is going to be y greater than or equal to what? -4. So my domain is what my x's are on my graph. What are all the values of x? And the range is going to be all the values of y. Well, the smallest y on this picture was -4, and it just keeps going up and up and up. Maybe not as fast, but it's going up. So then on forever. Questions about that one still? Alright, let's look at another one. How about, let's see. How about number 2? Anybody have any questions on number 2? Who said yes? Anybody? You?
Is that the one where you're finding the test score that's not there?
Right.
Yep.
Okay, so that one's on the test too, with a little bit of different scores, a little bit of different names. But essentially, we had 1, 2, 3, 4 test scores, and there's going to be a total of 5 tests. So I'm going to put in my test scores. I have 1, 2, 3, 4, 5 tests, remember? 91, 90, 83, 77, and some other test. So that when I added those all up and divided by what? 5. So when I add all those up and divide by 5, it has to equal 87. So the first thing I have to remember is that the mean is what I get when I add up all of my test scores and divide by the number of tests I have. Then I have to remember that I want that number divided by 4 to equal whatever they tell me my total is going to be. Could you guess and check here? You probably could. It would just take you a little longer. But if you remember that the mean is just all the test scores, add them up, divide by 5, now we can solve this pretty fast. Because what could I do with the 5 on both sides? If I was doing this really nice and algebraically, I could multiply both sides by 5, which would make sense because I'd want to get an average of 87 on all 5 of my tests, right? So I'd have 87 times 5. And then what am I going to do with all these numbers over here that are adding? I'm going to subtract them. You could add them all together and subtract them as one big bulk number. Or if you are feeling lazy like I am this morning, we could just divide them or subtract them each individually. So if I took my total amount and subtracted by the other 4 test scores, I would find out that on my final test, Elena would have to have a 94% in order for her average on all of her tests to be 87. Questions about that one? Good. All right, what else? Did anybody not remember how to make their histogram?
You know, I went over that yesterday a couple times, so.
Is there anybody else who still does not remember how to make their histogram? One thing I just want to point out again about histograms is that you have bins on the bottom with the scores. I wouldn't even do it on my calculator, and the frequency or the number of times something occurs is on the side. This is one of those 5% of the time I wouldn't bother. And I'd say, oh, well, if it has to go up by 10, and my smallest number looks like 72, I'm just going to start my bins at 70. And go from 70 to 80 to 90 to 100 to 110 to 120, whatever. Okay? And then I just count how many numbers fall between 70 and 79. So I have like 1, 2, 3. I think I have 3. So over here, my 70s bin would be 3 high. And then I'd go to my 80s. And what would happen if I missed a 70 and I found it later? I could just make this bin 1 higher. Oh, there I go, and I'm still done.
And I like how you just pointed out that it went to 79, because when you hit that next one, 80
Then
goes
I'm in
in.
the 80s bin.
Right, yep.
So once I hit 80, I'm switching to the next bin. So within 80, I have 1, 2, 3, 4, 5, 6, 7, 8. 8, so this one's going to be a lot bigger. And sometimes I write the 3 and the 8 right on them just so I can keep track, but other than that.
And something you said when we did this unit that really has stuck with me is that we remember to round up to that next bin, because if I'm in math class and I had a 79%, I'm at a C range, but
As
the
soon as I
minute,
hit a B,
Right.
I'm at a B.
right.
Yep. Other questions about that one? Alright, let's see what else we got on the real test. Sometimes there's